Functional programming in Python enhances data processing efficiency. The map function applies a given function to all items in an iterable, transforming data seamlessly. The filter function extracts elements meeting specific criteria, refining datasets. Lastly, reduce aggregates elements into a single value, streamlining complex calculations. These functions empower developers to write concise, readable, and efficient code. Functional programming in Python leverages map open parenthesis, close parenthesis, comma filter, open parenthesis, close parenthesis, and reduce open parenthesis, close parenthesis for efficient data processing. Map open parenthesis, close parenthesis applies a function to each item in a collection, transforming data elegantly. Filter selects elements meeting specific conditions, refining datasets. Reduce aggregates data into single values, streamlining complex operations. These functions embody functional programming principles, enhancing code predictability and conciseness. Functional programming in Python shifts focus from imperative loops to function application on data collections. It emphasizes immutability, where data structures remain unchanged, and higher-order functions, which accept or return other functions. This declarative style, embodied by map, filter, and reduce, allows for concise, predictable, and testable code without explicit iteration. Mastering map, filter, and reduce transforms complex loops into concise, maintainable code. These functions enhance readability by clearly signaling transformation, selection, and aggregation. They often outperform loops, especially with large datasets, due to optimized C-level execution. Widely used in data science and analytics, they are essential for writing Pythonic code aligned with industry standards. The map function elegantly transforms data collections by applying a specified function to each element in an iterable. It returns a map object, an iterator, which is memory efficient for large datasets. To view results, convert the map object to a list or tuple. This approach enhances code readability and performance, especially in data-intensive tasks. The map function applies a specified function to each item in an iterable, returning a map object, an iterator in Python 3. This approach is memory efficient, especially for large datasets, and supports multiple iterables. Unlike Python 2, which returned a list, Python 3's iterator requires conversion to a list or tuple for result viewing. Using map, with a named function, we convert Celsius to Fahrenheit for clarity and reusability. The function Celsius to Fahrenheit transforms temperatures, enhancing readability and debugging. Applying map to temperatures C, we obtain Fahrenheit results: 32.0, 50.0, 68.0, 86.0, 104.0, 212.0. Named functions support unit testing and multiple contexts effectively.